So we have a part two here, which is like we have already understand that what is LLM foundation, API keys, use the chat models, used Hugging Face and local model, used messages and from the structure output. So now you know me guys, we have to complete everything about RAG in this video. But while teaching generative AI, I got to know the best way of teaching this is project based learning. So if you want to learn something, then we have to learn everything, or we have to learn that topic using the project. So let's start. So guys, we have a course made AI is like it's a type of AI powered study assistant designed to help students interact with their learning materials or efficiently. And modern students rely on multiple sources of study materials such as lecture notes, textbooks, PDF, and research papers. These documents are often long and difficult to navigate, making it time consuming to find specific information. So, CourseMate AI aims to solve this problem by allowing students to chat with their study material. So, we are going to build that kind of application where you can upload your PDF and then you can chat or you can talk with your PDF. So, Cosmate AI aims to solve this problem by allowing students to chat with their study materials instead of manually searching through pages of context. Students can simply ask questions and receive accurate answers extracted directly from their documents. By leveraging retrieval augmented generation, CourseMate AI combines the document retrieval with large language models to provide context aware explanations, summarize, and answer from students' own study resource. So what this means, so here we are going to develop a RAG app. So CourseMate AI combines document retrieval with large language model to provide context aware explanation. So we are going to connect our document with the LLM. So LLM is going to visit your document, then it will answer whatever you want. So we have a plan here development. So now to develop this kinds of system, we are going to follow some steps, and the steps and the good thing is we are going to apply each and every step and create our project as well. So तो पढ़ाई भी हो जाएगी एंड प्रोजेक्ट भी बन जाएगा. So development plan is what user uploads study material, students upload learning resources such as PDF, lecture notes, textbook, research papers. Document loading. So second step is like first they upload their PDF, and second step we have a like document loading. So document load basically it means they are reading your document loader means they are reading your document. So system loads the document using document loader tool, and system loads the document using document loader. So here we have a goal is like convert raw files into document objects that can be processed. So we are here now converting raw files into document object that can be processed. So you may clean the document as well. Okay, so then we have in the next, like in the third step, we have a text splitting. Okay, which is like chunking. So documents are usually too large for LLM context windows, so we split them into smaller chunks. So LLMs is like it cannot process, it cannot take your all the documents. So what we have to do, we have to split them. Okay, you have to split them into small chunks. So because LLMs context window is like not so much good. So documents are usually too large for LLM context. So context window means how much they can take at once. So documents are usually too large for LLM windows. So we split them into smaller chunks. Chunking improves retrieval accuracy. Then we have a third step, embedding generation. Each chunk is converted into a vector embedding Embedding models transform text into numerical vectors. So each chunk is going to be converted into a vector embedding. Embedding models transform text. Okay, embedding models transform text into numerical vectors. So embedding models is going to transform your text into numerical vectors. Like we have a gradient descent optimization, that's a sentence, and they are converting their vector gradient vector is 0.23. Then this is a like a vector, and if we have this thing, then that's basically dimension. You can say dimension 1, dimension 2. So these vectors represent semantic meaning. Of course, they represent semantic meaning. Then we have a vector database stores. All embedding are stored inside a vector database. The vector database stores embedding original text chunks metadata. Okay, so they store embedding original text chunks metadata. Then user asks a question. Now the student interact with the system. Query embedding, the question is also is like going to convert into embedding, and our PDF is first converted into chunk, then chunk is also going to convert into embedding. Then when we are like user is asking something, that's the user, so that prompt is also going to convert into what, into a query embedding. So we will compare the query embedding, we will go to the close where to the vector, okay, which is like similar to the query embedding that we have inside this vector database. So we will try to find a similarity between the uh, vector which is stored in a vector database, and also about the query embedding. So we are trying to find the uh, similarity between the query embedding and the vector that we have stored in vector database. So then we have a similarity search. The vector database will form semantic similarity search. Go find chunks that are most relevant to the question. So we are going to find that chunks from the vector database that are most relevant to the question, that are most relevant to the query embedding. So retrieval component, the retriever select the top k relevant chunks. These chunks from the context. LLM answered. LLM's answer based on the context. The LLM answer. RAG is what? RAG is like document loaders, text exploiter, database retriever, retrieval augmented generation. Okay, now let's create this, and also I will teach each and everything while making this project. All the best. Text exploiter is like most of the embedding models, and the large models have a context window, and they cannot take infinite tokens at the same time. So for that we have to use the text splitting. So better retrieval in RAG we search through vector embeddings. If the document is too large, embedding become less precise. Okay, if the document is too large, embedding becomes less precise. A smaller chunks allows the system to retrieve only the most relevant piece of information instead of the whole document. So if you have like smaller chunks, then it will work like best. So we can find a better retrieval. Smaller chunks allow the system to retrieve only the most relevant piece of information instead of the whole content, instead of the whole document. More accurate, more accurate embeddings Embeddings work best when the text represents one clear idea or topic. Okay, so embedding work best when the text represents one clear idea or topic. If you embedded very large text, multiple topics mixed together, semantic meaning become blurred. So chunking ensure each embedding represents a focused concept. Okay, so more accurate embeddings, how you can do this. Embeddings work best when the text represents one clear idea or topic. If you embedded very large text, multiple topics mixed together, semantic meaning become blurred. Okay, if you're like mixing everything in topics, so it becomes very blurred, semantic meaning not working there. So faster processing is what, like working with smaller chunk, speed up embedding creation, speed up similarity search, fasting processing working with smaller chunk. If you have a smaller chunk, then you can speed up embedding creation, speed up similarity search in vector database, Chroma, Paint, Code Large a large document would make the pipeline slower and expensive. Large documents would make the pipeline slower and expensive. We are going to create three types of text splitting method: character based splitting, token based splitting, semantic meaning based splitting. Character based is what character based splitting is what character based splitting is the method is the simplest method of text splitting. It divides a large document into a smaller chunks. So it divides a large document into a smaller chunks based on the number of characters without understanding words, token, or meaning. So it basically divides based on the number of characters without understanding words, token, or meaning. Token based splitting is what token based splitting is what token based splitting is token based splitting divides a document into chunks based on number of tokens, not character. Since LLMs process token instead of words, this method aligns better with how models actually read text. So, token-based splitting is what? Token-based splitting divides a document into chunks based on the number of tokens, not character. Since LLMs process tokens instead of words, so LLM process token instead of words. This method aligns better with the how model actually read text. Then we have a word semantic meaning based splitting. Semantic meaning based splitting divides a document into chunks based on the meaning and structure of the text rather than character or tokens. The goal is to keep complete ideas together so that each chunk contains a coherent piece of information. Text splitter. Deep learning is a specialized area of machine learning that uses the neural networks with multiple layers to automatically learn complex representation from large large amount of data. So and natural language processing is another important area of artificial intelligence that focuses on enabling ability to understand, interpret, and generate human language in tasks such as translation, chatbot, and sentiment analysis. So that's the basically text here. So what it does, so vector database, vector store here we have. So first of all, if we talk about our project, we are creating a AI assistant which is going to search our PDF and give answer based on that. So vector store is what like we have a PDF, then we are converting into chunk, then chunk 1, chunk 2, chunk 3, then we are converting into let's say we have a lots of data, then we are going to create a chunk n. So after this our next step will be to create embedding of the chunk. So now we have created the embeddings. Then we have created is what we have created what here we have created embeddings. Then we are going to put our embedding inside the vector store. So now after this we need to store these embeddings, and for that we are going to use vector store. So now the question that might comes to our mind is that we have already have many types of database like MySQL, GraphQL, MongoDB, etc. So why we need only like vector database? Because these things MySQL and all, they work only on the exact word, but vector database works on the meaning. So that's why vector store answer is actually simple. Let's understand. So let's see, you upload a PDF like PDF file, and after syncing it you get around 1 lakh chunks. Now suppose you embedded model produces embedding with this 512 dimension. Okay, so okay, 1 lakh embedding. Then let's say this is a normal database and user gives a query. What does the node say about natural language processing? So the query is the first converted into embedding. What does the node say about natural language processing? Unlike embedding, and you are searching from this. Okay, so what is that here? So the biggest problem is that is this one 512 dimension embedding is different from all 1 lakh embedding in our database. So we connect conduct a similarity search with all the 1 lakh embeddings. Okay, we are working at how much big and time complexity, and user searching for 1 lakh time and finding out this data set can become more big, so they are not reliable option for similarity search. So you're like checking every step there. Okay, so whereas vector store use approximate nearest neighbor algorithm like HNS, HVFP, and all of these are indexing technique. Now we are not going to see all, but let's see an example why they are fast. Inverted file index. Let's say we divide our database in clusters, in 5 clusters. Okay, we are going to divide our database in 5 clusters using k-means or any other algorithm. So we will have about 20,000 embedding, and all of them have some sort of similarity. After we calculate the average embedding of all the 20k embeddings, we can call it centroid. Now we have 5 average embedding. Now for the query embedding, we can find which cluster is suitable for searching, and we search in those 20k embeddings is actually 5 times faster than normal database. So now for the query embedding, we can find which cluster is suitable for searching, and search in those 20k embeddings. This is actually 5 times faster than normal database. What is here? We have vector store, feature data store, normal database structure, data text, number rows, vector database embedding works like this. Search type exact match query, like Mr. Movie interview as indexing D3 has banking user record and comparison of version. Then we have our indexing like H and SW, most movie about travel or space travel similarity AI is recommended RAG to science similarity vector database. Then we have what now there are many vector stores, like these are widely used as framework like Langchain and Llama Index. Okay, Llama Index. So these are widely used in framework like Langchain, Llama Index. Chrome of Yes and I vector. Enough yapping. Let's see how to use one. So retrieval. Now before understand retrieval, let's go through our diagram to understand the application that we are going to create, and also we are going to see of retrieval in the application. So phase one, what we are going to do, this is our like document. Okay, then we are going to upload our document, and we have a document loader. It is going to extract all the things. Then we have a text explorator which is converting into chunk. The chunk is going to convert into embedding. The embedding is going to store in the vector database. Then we have what, then we have query. Then we are going to then we have query vector store query. Then query is going to query is like we have a query is going to convert it into embeddings. Then embedding is what we have a retriever which will find the relevant answer it will find from the vector database. So then it will like gives us the what similar chunks for query. We also call this relevant context. Then we have a query. Then we have a query, similar chunks for query. Then we have a prompt, and then LLM. Okay, so we have a similar chunk we find for query. We also call this relevant context plus query plus this. Then we are giving to the LLM is providing us answer. Retriever task is ask a question. Yeah, a retriever takes a query, a user query, and returns the most relevant document or strings from a database. Now, there are two types of retriever: by data source, Wikipedia, Arcsys, PubMed, etc. But retriever says similarity MMR, multi-query by data source. When we talk about retriever using data source, we mean retrievers so that fetch information from a specific external source or database instead of your own vector store. These retrievers connect to APIs or datasets and return relevant document for the query. Let's see an example by data source. So I hope now you get this gist by data source work. Same code can generate the result from the Wikipedia and other types of retrieval by data source. So by retrieval strategy, first go to the vector store code and important information. My retrieval strategy, first go to the vector store code for important information. Now you know that retriever are only used for basic similarity search strategy. They also provide some more for search strategies that make them more useful, and they are runnable as well, which make them suitable for building chains. Search strategy in most RAG system, retriever mainly used for retrieval strategy. These are the one you will see most often in real projects and tutorials. Similarity search, most common MMR, max marginal relevance, multi-query retriever. So we have a retrievers search strategy, similar search, similarity search. The system compares the query vector with the documents vector using similarity metric like cosine similarity dot product gradient. The retriever finds the most similar vector. Pocket documents are retrieved. Then we have a retriever search strategy MMR maximum marginal relevance. Let's understand with an example. Imagine you are building a rack system to our student. Your knowledge base contain many chunks about gradient descent. Your database chunks look like this. Gradient descent is an optimization algorithm used in machine learning. Gradient descent minimize the loss function. Gradient descent is an optimizer that minimizes the loss function near a user. This is a gradient descent node for training support vector machine supervised learning. So you have these database tends to look like this. So when you ask the question about gradient descent, though normal similarity search find the most similar chunks the query embedding and gives chunk 1, chunk 2, chunk 3. And if you see carefully, all these chunks are seeing the same thing. So this waste context window token use case. Okay, so information diversity. The LM doesn't learn information. MMR stands for max marginal relevance. Its goal is to balance two things relevance to the query, diversity among retrieved documents. So it gives you the different information. So instead of retrieving similar documents, it retrieves different but relevant document. Okay, so search strategy, multi-query, imagine you better access system for machine learning node. Contains these chunks. Your database contains what? Your database contains these chunks. Okay, we can see and this. Now the user asks what is gradient and retriever might return. When you are using multi-query, they can return product of machine. Okay, chunk one and chunk three with machine learning. Query. But notice something. These are some relevant chunk like chunk two. It might not be retrieved. Why? Because their query wording is limiting. Core programming. A single query may not capture all the way of concept can be expressed. A single query might not capture uh, all ways. Always a concept can be expressed. For example, what is gradient descent? A single query might not capture all way of concept can be expressed. For example, what is a gradient descent? Could be as explained gradient descent. How does gradient descent work? Optimization algorithm using neural network. The core problem: a single query might not capture all the way of concept can be expressed. For example, what is gradient? Could be explain gradient descent. How does the gradient descent work? Optimization algorithm, different forwarding, different embedding, different strategies. This is where multi-query retrieval helps. So instead of using one query, it generates a multiple variation of the query using an LLM. So now the pipeline becomes user query. LLM generate multiple queries. It reverses for each query, combine all relevant documents or audit document. So now finally complete our project. So guys, finish.